Hello everyone, welcome to LeetCode Day 30 challenge. In this we have to rotate an array. As you can see, we will be given a k that can be an integer, and we have to do a rightward shift in this array. Like this 5, 6 and 7 will go in the beginning, and 1, 2, 3, 4 will come here. Okay, so this is the question, and this also has a follow-up that can we solve this in O of 1 extra space. So let's first talk about the brute force solution for this problem. So this was the question which I was having. So this was my array and this was the value of my k. So the first approach, that is the brute force approach, will be to come at the index which is like 3 from the end. So that will be array of size minus k. So what is array of size? 1, 2, 3, 4, 5, 6, 7, and we have to come at this index. 1 minute. We have to come at fourth index. So the size of the array is 7 and this is 3. So this is equals to 4. So with this we will be coming to the index which we want, this index. So let's say I have an iterator, let's say I here, and I will be making another vector, and in this vector I will be pushing all the values from 5 to the end. So this will be 5, 6, 7, and this will be my array, and this will be, let's say, ARR2. And now I will be making another array, let's say ARR3, and I will be pushing all the values from ARR2 to ARR3 like this, and I will be pushing from here till I won't exceed I, and I won't even touch I. I will be making a condition that it should be less than I. So this will be 1, 2, 3 and 4, and I will be just returning this, and this will be my answer. So this will get accepted, there is no problem in this, but the time complexity will be O of n and the space complexity will be also O of n. But in the follow-up we were asked that we have to solve this problem in O of 1 space complexity. So how can we solve this in O of 1 space complexity? So for that we need some observation for this problem. So talking about the most optimized solution. So in this, first of all, we can see that this is the array. So we want this part to come here, okay, and we want this part to come over here. So first of all, let's reverse the entire array. So that will be 7, 6, 5, 4, 3, 2, 1, and they will be having the index 0, 1, 2, 3, 4, 5 and 6. Now my job will be, so my job is to reverse all the values from 0 to k. So this. So first I will reverse this value. That will be 5, 6 and 7. And my job will be to reverse all the values from k till the end. So that will be 1, 2, 3, 4. So with this we can just reverse all the values, and this will be our answer. So now let's move to the coding part for this problem. So now moving to the coding part. So we have a void return type, so we cannot return anything. We have to just make real changes in the nums. Okay, so how we will do this? So first let's say that let's talk about the corner case first. So let's assume that our nums vector is small, like let's say its size is 5, whereas the value of k is, let's say, 100. So in this we will be getting a runtime error because there are no 100 indexes. So what we can do is we can reduce the size of the k, because it's going in a circular manner, so we can just do a mod and it will work perfectly fine, like k is equals to k mod nums dot size. So now I can say that my k will be either less than nums of size or equals to nums of size. Okay. Now what I will be doing is I will be reversing the entire array. Reverse nums dot size comma nums dot end. So this will be nums of begin. So we'll be reversing the entire array, and then we will be reversing the array from 0 till k. So that will be reverse of nums dot begin to nums dot end. Sorry, no, it will be from nums dot begin plus k, and then we will be reversing the second part. So that will be reverse of nums dot begin plus k till nums dot end. and with this, let's try to run it. It's showing no errors, so let's try to submit it. So it got accepted with no problem, no errors. So that's how you can solve this problem. This was a very easy question. Thanks for watching this video. If you like this video, please consider subscribing. Thank you.